Hidden in the mountains of southwestern China sits a machine that listens to the universe. It has heard signals from the edge of everything we can observe, bursts of energy that traveled billions of years just to arrive here. But this machine has a secret. By every rule of engineering, it should not work. It is too big to move, yet it must move to function. Its most important component cannot touch the structure, yet it must hold a position more precisely than almost anything ever suspended in open air. And its greatest enemy is not in space at all. It is here on Earth, and it is us. 3 problems. Each one should have made this machine impossible. This is FAST, the largest radio telescope ever built. And this is how China built an ear big enough to hear the universe. First, understand what this machine is. A radio telescope does not look at the sky. It listens to it. Stars, galaxies, and dying suns all emit radio waves, and the bigger the dish collecting them, the fainter the whispers it can hear. For decades, the world's largest dish was 305 meters across in Puerto Rico. China decided to build one 500 meters across, wider than 5 football fields end to end, inside a natural bowl-shaped valley in Guizhou province, carved by millions of years of limestone erosion. The valley solved where to put it. But the moment engineers began designing the dish itself, they collided with the first problem, a contradiction at the heart of the entire project. Problem number 1. The dish is too big to move, but it has to move. A radio telescope works by pointing at a target in the sky. To study different objects, it must point at different places. Smaller telescopes rotate on mounts, tilting and turning to track whatever astronomers want to observe. FAST is 500 meters across. It sits inside a valley with mountain ridges rising on all sides. No mount on Earth can rotate a structure this size. No mechanism can tilt it. The dish is fixed into the landscape, permanently. A telescope that cannot move can only observe whatever drifts directly overhead. A dish of this scale, frozen in one direction, would waste most of its own power. Engineers solved the contradiction in a way that sounds impossible. They made the dish move without moving. FAST's surface is not one rigid reflector. It is 4,450 individual triangular aluminum panels, each connected to the structure beneath by independently controlled actuators, mechanical arms that push or pull each panel with precision. The entire 500-meter surface can reshape itself in real time. When FAST targets a source in the sky, the control system reshapes a 300-meter section of the dish into a perfect parabolic curve aimed at that target. As the target drifts across the sky, the active section travels across the dish, panels rising and falling continuously, holding the perfect shape while the shape itself moves. The rest of the surface waits its turn. A dish too big to move. That is always moving. One panel at a time. Problem 1. Solved. But a reshaping dish created the second problem, because the signals it collects must all arrive at a single point. A point hanging in midair. Problem number 2. 30 tons, floating above a 500-meter void. Every dish reflects incoming signals to one focal point above its center. At that point sits the receiver, the instrument that actually hears. On normal telescopes, the receiver is bolted to a rigid arm attached to the dish. The dish moves, the receiver moves with it. At FAST, that is impossible. The dish reshapes constantly. The focal point shifts with every new target. A rigid arm spanning a 500-meter dish would be a megastructure in itself, and it would block the very signals the dish collects. The receiver, a 30-ton cabin packed with instruments, had to float freely above the dish, repositioning itself continuously to wherever the new focal point moved, and it had to hold each position to within 10 millimeters, the width of a finger, while suspended over a 500-meter open void. Engineers built 6 towers around the rim of the valley, rising above the ridgeline. From these towers, 6 steel cables run down to the cabin suspended at their center. By extending and retracting each cable independently, The control system positions the cabin anywhere in its operating zone and holds it there within 10 millimeters against gravity, against wind, against the swing of its own 30-ton mass. 6 cables, 6 towers, a 30-ton instrument floating in open air, chasing a moving point above a dish that never stops reshaping. Problem 2, solved. But the telescope that now existed was so sensitive that it faced one final enemy. And this enemy was not in the sky. Problem number 3, the enemy is us. The signals FAST detects are almost unimaginably faint. A radio burst that traveled billions of light years arrives at Earth carrying less energy than a snowflake landing on the ground. To hear whispers that quiet, the telescope must hear nothing else. And modern human civilization never stops shouting. Mobile phones, Wi-Fi, television broadcasts, car electronics, power lines. Every device around us leaks radio frequency noise. To FAST, operating at full sensitivity, a single mobile phone switched on nearby would be as loud as the cosmic signals it was built to detect. The most advanced listening machine in history could be defeated by a phone in someone's pocket. The first defense was the site itself. The Guizhou Valley was chosen not just for its shape. The mountain ridges surrounding the dish form a natural radio shield, blocking signals from the outside world across a wide arc. The same geology that created the bowl created the silence. Then, China built the silence outward. A 5-kilometer radio quiet zone surrounds the telescope, one of the largest electromagnetic exclusion zones around any scientific facility on Earth. Inside it, mobile phones are prohibited. Vehicle electronics are restricted. Any equipment entering the zone must be certified electromagnetically silent. Monitoring stations around the perimeter scan continuously for interference. When a source penetrates the zone, the observation schedule shifts in real time, moving to cleaner frequencies until the intrusion is eliminated. The most sensitive ear on Earth needed silence. Engineers built the silence around it. Problem 3, solved. FAST became fully operational in January 2020. A dish 500 meters across, the largest single-aperture radio telescope ever built, a record it holds by an enormous margin. 4,450 self-adjusting panels, a reflector area of roughly 196,000 square meters, a 30-ton cabin positioned to 10-millimeter precision by 6 cables, a 5-kilometer zone of engineered silence. Total cost, roughly $180 million US, less than a single modern passenger aircraft. Since switching on, FAST has discovered hundreds of new pulsars, more than all other observatories combined over the same period, and detected signals from sources at the edge of the observable universe. A dish that moves without moving, a receiver that floats on nothing but cables and mathematics, and a valley where human noise is not allowed to exist. That is FAST, the largest eye humanity has ever turned toward the universe. Next week, we're visiting the world's tallest twisting skyscraper, a building so advanced it cuts wind loads, saves energy, and redefined China's skyline. Shanghai Tower. Subscribe, and we'll see you next week.